Hi, this is Shovik from Team Binary Sentience. The problem statement for today is every engineering team building an AI product faces the same question. Should we call a managed API or self-host an open weight model on GPU? The answer depends on your token count, latency requirement, traffic patterns, and cost projections across growth scenarios. This particular tool is designed to exactly tackle this problem. Now let me give you a quick demo. I'll go ahead and paste a real life workload. Press the Analyze button, and while the tool thinks, I'll quickly give you a brief description of the architecture. This is basically a four-stage Google ADK pipeline. It can be roughly divided into two stages, stage one and stage two, with two agents being in the two different stages. In the first stage, we have the parsing and the judge agent. The parsing agent basically extracts a structured spec from the description, including two fields that most calculators miss, which is latency SLA and the traffic pattern. And the other agent that we have is the judge agent, which validates the spec. If anything is ambiguous, it goes into the advisory mode and asks exactly one clarifying questions rather than silently guessing. Let's see what the tool came back with based on our first question. So this is how you see the judge agent is at work. It has come up with a clarifying question because in our initial prompt, we did not specify or give much details about the token count, and the tool flagged that. I'll give a follow-up answer to this question. I'm stating that my input would be roughly around 50 to 80 tokens and my output would be around 20 to 30 tokens. I'll press the Analyze button again, and while the tool is doing its own calculations, I'll quickly walk you through stage two, which is the pricing and the reasoning agent. The pricing agent basically calls an MCP server that I built, and then it calls the cost engine bridge, which is pure Python, no LLM, so it does the deterministic math. And finally, the reasoning agent gets called, which synthesizes all the cost data, latency classification, toolchain friction into one structured recommendation. The key architectural decision is stage two runs only when the judge agent gives a clean pass verdict. On the first turn, when we gave the first question, the spec was still ambiguous, so the stage two never ran, right? It only ran when we gave the clarifying information. And that actually saves significant time. It saves around 40 seconds and several API calls on every clarification round. Now let's go back and see if we have some results. We do have. The tool shows you the structured assumptions over here, and then it gives you the recommendations. As you can see, the verdict is open with GPU, and this is the clearest possible recommendation. We also have a hard latency requirement banner at the top, which says managed API is disqualified because of the hard latency requirements. And then we also see that it talks about moderate toolchain friction. It says GCP TPU v5e, which is its recommended GPU, is has toolchain porting friction, which might take around 1 to 4 weeks of engineering work, right? And if we scroll down, it will also show you the structured decision making framework. The primary decision was managed API versus self hosting, and then if self hosting, which model approach. So it gives you all these nice details which helps you decide. I'll close the demo by saying that, this is a tool that I believe is going to help a lot of companies as companies become AI first. It is live at Kaggle AI Infra Cost Advisor.versal.app. All the details, the GitHub link is in the write up. I'm Shovik from Team Binary Sentience, and thank you so much.